Okay, I'm recording section 2.4, and the objective is use postulates and diagrams. Use postulates and diagrams. The postulates are going to be on the front, and the diagrams we will do on the back. Statements accepted without proof are called postulates. These are like baby steps, baby ideas. And statements that are proved are called theorems. These are larger steps or larger concepts. They need to be proved. All right, we're going to go through and review some of the postulates that we already have and then add on. And these are ones that you have to have memorized, so take note and pause when needed. All right, the first one's a ruler postulate. If you have a segment, then you call it maybe x, y. And if you were to hold up a ruler next to it and measure, each one of these coordinates has a number associated to it. So let's say this is a 2, and this would be a 6. The way to find the measurement of this segment, you would take the coordinate at x and subtract the coordinate at y and absolute value it. So you'd have the absolute value of 2 minus a 6, which would give you a negative 4, and when you absolute value it, you'd get a positive 4, because distance is always positive. The segment addition postulate, if you have a segment and you have 3 points on it, and the second point does not have to be the midpoint, when you add them together, the segment AB plus your segment BC would equal the total segment AC. So the two parts equal the whole. Protractor postulate is going to be when you have an angle, and let's say that this ray has a letter X associated with it and this one has Y. When you draw, or when you put your protractor on here, and the center has to be at the vertex, and you take the number that's associated with X, let's say that that looks like about 89 degrees, and let's say Y has associated with 58 degrees. What you would do is you take the absolute value of your degrees at X and subtract the degrees at Y. So in our case, you would have the absolute value of 89 degrees subtracting 58 degrees, and that's going to give you a 31 degrees, and you absolute value it, and it's going to be positive 31 degrees. And that would be the measure of that angle. The angle addition postulate, if you have an angle drawn and then you have a ray in the interior, does not have to be an angle bisector. And if I label this A, B, C, and D, then you're adding these angles up. The angle ABC plus the, this should be measure. The measure of that angle plus the measure of angle CBD equals the large angle, which is the measure of angle ABD. So the two smaller angles add up to the larger angle. And that's angle addition postulate. Okay, the fifth, now this is a new postulate for you, but there are two line postulates. So the fifth postulate is line postulate. It should be a 1 here. And this one should be line postulate 2 here. So just change those, please. Okay, line postulate 1 says, through any 2 points there exists exactly one line. Through any 2 points there exists exactly one line. So this means that if you have any 2 points, you can always play dot to dot and create that line. So if you have a point A and you have a point B, voila, you'll get a line through that. So this is exactly 1, no more than 1. That's the first line postulate. The second line postulate says it's a reverse of the first one. A line contains at least 2 points. So if you have a line contains least 2 points. So if you have a line started out, let's call it line L, you for sure have 2 points. You have an infinite number of points, but the least number of points you have is 2. So it's the reverse basically of line postulate number 1. Okay, line intersection postulate, this is postulate number 7, says if 2 lines intersect, then their intersection is exactly 1 point. If 2 lines intersect, then their intersection is exactly 1 point. Okay, so I want to draw 2 lines. So you have 2 lines and they intersect. Let's call this line L, and here you have line K. They intersect at exactly 1 point. Let's put a capital P for that point. And it's exactly 1 point, no more than 1 point. Plane postulate. Now, number 8, the 8th postulate is called the plane postulate. There's 2 plane postulates. This is going to be plane postulate number 1. And that says through any 3 non-collinear points, there exists exactly 1 plane. So through any 3 non-collinear points, there exists that should be E-X-I-S-T-S. There exists exactly 1 plane. Alright, to draw a picture of that, starting with the points, capital A, capital B, capital C, they're to be non-collinear. So through any 3 non-collinear points, you can get exactly 1 plane. The plane postulate number 2 is reversing that. A plane contains at least 3 non-collinear points. A plane contains at least 3 non-collinear points. So now we're starting the reverse. We're starting with the plane, and inside the plane there are at least 3 non-collinear points. There are an infinite number of points, but at least 3. Okay, the 10th postulate, line in a plane postulate, says if 2 points lie in a plane, then the line containing them lies in the plane. If 2 points lie in a plane, then the line, that's a then, the line containing the 2 points lies in the plane. Alright, there's not much room for a picture here, but let's go off into the margin. If you have 2 points, call them A and B, and they lie in a plane. Here's our plane. Let's call it capital script plane M. So those 2 points lie in a plane. Then you know that if you have 2 points, there's exactly 1 line. So here it is, exactly 1 line. And that line lies in the plane. So if 2 points lie in a plane and 2 points make exactly 1 line, that line also lies in the plane. Okay, the last postulate that we're going over right now is plane intersection postulate. It says if 2 planes intersect, then their intersection is a line. If 2 planes intersect, then their intersection is a line. And I'm going to attempt to draw this. So if I have a plane and I have another plane, okay, this is when you cannot see, so I'm dashing it. It comes out in front. And so I'm going to emphasize this is the line. So let's say that you have plane P and plane M, and they intersect at a line L. So it would be like two walls intersecting at a corner, and the corner is representing the line. So if two planes intersect, then their intersection is a line. There's a definition we need to go through, and the definition is line perpendicular to a plane. Let me butt that up there. A line perpendicular to the plane says if a line is perpendicular to a plane, then it is perpendicular to every line in the plane at the point of intersection. So let's write all that out. If a line is perpendicular to a plane, here's my symbol. If a line is, here's this perpendicular symbol. If a line is perpendicular to a plane, then it is perpendicular to every line in the plane at the point of intersection. So let's draw this. Here I have a plane. Let's call that plane capital M. And then we have this line perpendicular to the plane. Let's call it line L. And it's going through the plane at a perpendicular or at a right angle. Now, if this line is perpendicular to the plane, then it is perpendicular to every line in the plane that intersects at this point. Let's call this point of intersection P. And here are some lines in the plane, and line L would be perpendicular to this line. Let's call that line K. And line L would be perpendicular to another line in that plane, so long as it's intersecting at P. Let's call this line M. Now notice that's a little script m. The plane is named with a capital script M. And then if you had another line intersecting point P, let's call that line R, lowercase script r. So these three lines, actually any line that is perpendicular to L, they have to intersect at P. So back to the full definition. If a line is perpendicular to the plane, we are saying that L is perpendicular to plane M. Let's write it this way. Line L is perpendicular to your plane M. That's a capital script. Then you're going to have the line being perpendicular to every line in the plane. So L is going to be perpendicular to M. L would be perpendicular to R. L would be perpendicular to K. And let's make this R a little bit better. Okay, so it's going to be perpendicular to every line in the plane that intersects at the point P. Okay, that's it for the first half. We're going to go to the back and do some work with diagrams.